All right. I mentioned earlier that we're going to have Adam from Judoscale give a talk, and so we're inviting him up right now. Adam, working in Judoscale, has tons of experience in working with and seeing many different applications and the performance capabilities and the challenges they run into. His blog, the Judoscale blog, is fantastic, and it's one of the best resources around that. And Adam is deeply knowledgeable about Sidekick and background jobs and how to manage growing pains. And so I'm excited to have him talk. 5 steps to resilient job queues. Thank you, Adam.
All right, so we're going to get kind of tactical for the next 5 minutes. It's going to go kind of quick, but I will have a link to the slides at the end if you want them. Because I think most of us in this room work with job queues and worker processes in some way, and I'll bet many of us are familiar with fragile job queues. Perhaps you've experienced job queues backing up with hundreds or thousands or hundreds of thousands of jobs. Maybe worker processes screaming at you that they're running out of memory, or maybe worker processes that are unresponsive and crashing. The opposite of that is resilient job queues. They flow smoothly without manual interruption. They're cheap and efficient to run, and I want to show you how you can do this in 5 steps. And it doesn't matter what job backend you're using, job queues are job queues. So let's dive in. Step 1 is explicit latency SLOs. Let's unpack this a bit. Latency is just how old is the oldest job queue in a given queue. Might be also be called queue time. And SLO is service level objective. This is just the moment that that latency goes from fine to not fine, okay? And every job in your system has an implicit SLO, such as maybe you're sending a 2-factor authentication code. The user needs to get into your app. They're sitting, waiting for it. This needs to happen quickly. Let's say maybe 5 seconds. Maybe you're generating a video thumbnail. User's still waiting, but they understand it's going to take a little bit of time, so maybe that's 5 minutes. That's for you to decide. Maybe you're sending 40,000 privacy policy update emails that no one's ever going to read, but legal says you have to send them. So put some sort of time frame on it. Maybe it's 5 hours, right? It doesn't matter what these times are. The point is, don't make assumptions. Actually encode these SLOs into your queue names. Because when we're not explicit, we end up with job queues that look something like this. So tell me if any of these look familiar. And you're not alone. You're not alone if your job queues look like this. But the problem is there's way too many of them. It becomes an ops headache. And most of them are ambiguous. What exactly does urgent mean? Or maybe they're irrelevant. A privacy policy update email and a password reset email do not belong in the same queue. So mailers doesn't actually tell you anything about the behavior of the job queue. The alternative is latency-based queues, and they look something like this. Again, the numbers don't matter. What matters is that you've made a decision and encoded these SLOs into your job queues. So there's no ambiguity. You end up with a lot fewer job queues, and they're actionable, such as making latency-based alerts based on these queues. Because you have to know when there's a problem. And with job queues, there's a lot that you can monitor, but there's one metric that matters more than anything else, and it is queue latency. This is the one that tells you definitively whether things are fine or not fine. So you've encoded these latency SLOs into your job queues, so now you can just set up an alert based on each of those, and you'll know when there's a problem. But with resilient job queues, we want to avoid alerts entirely, right? That's kind of the whole point. And that's where latency-based auto-scaling comes in. Now, right, full disclosure, I run an auto-scaling service, but I'm not even going to mention the name of it because it actually doesn't matter what auto-scaler you use. The important thing is that you're auto-scaling your workers, right? If you're not, you're just burning cash, maybe thousands of dollars a month on worker processes that are idle 80% of the time, maybe more. And your job queues are just a ticking time bomb because eventually they're going to get overloaded with jobs and you won't have enough worker processes to handle them. So auto-scaling workers, the thing is you need to choose a metric to monitor. And most autoscalers are only going to let you autoscale with CPU, but CPU doesn't actually correlate with queue health when it comes to background workers. So what metric do you use? Queue latency. It's the metric that matters. And it doesn't matter which autoscaler you use as long as it does let you autoscale using queue latency. Because then autoscaling is super simple. You scale up when you exceed that SLO that you defined, and you can scale back down when your queues are idle or down below that SLO. But you're going to have times when maybe these latency-based queues don't fit everything, right? You're going to have some outliers. Such as maybe you're handling CSV uploads and you have this one user who uploads a 2 gigabyte CSV blowing out the memory of your worker processes, right? So one solution is you just bump up the memory of every worker, right? This is wasteful. You're upgrading all of your workers for just this one job. And the solution for that is dedicated workers for dedicated queues. And this allows you to selectively upgrade hardware. You just have this one worker that you upgrade, and then the rest of your workers you don't need to upgrade. Now notice, I didn't call this queue CSV uploads. We still want to encode the Y into the queue name. We'll call it high memory. That way, other jobs down the road that need this same queue can share that queue. But now we have a new problem, right? We've just added another worker, and maybe that worker is idle all the time, and again, that's just wasteful. So last thing we want to do is autoscale that queue to that worker to 0, right? In fact, lots of our queues could probably go to sleep when they're idle. It's really only that within 5-second queue that needs to be running all the time. The others can just wake up when they need to. So you tell your autoscaler, any autoscaler, to put those worker processes, scale them down to 0 when they're not being used. So those are the 5 steps. If you want these slides, or if you want one of these fabulous t-shirts, scan this QR code. I would love to send you one of these, and that's all I've got. Thank you very much.